first part had a low pass filter. The low pass filter has the capacitor and the resistor in parallel, which is what creates the low pass effect. No, which is what creates the it creates a low pass effect. So if you look at the graph over here, it's also an active filter, which is why the thing is amplified. But because it's low pass, it only allows like the low pass to pass, right? Which is why when the frequency is lower over here, we have it high, and then we have it reaching high frequencies and it's dropping down. For the second part, we have a high pass frequency, which is the second part down here, and it only has one resistor essentially that does the high pass part. And if we look over here at this graph over here, it's also an active filter, which is why it's amplified up here. But the fact that it's high pass means that it's very low when the frequency is low, because it only allows the high frequencies essentially to pass, which is why it's higher up here. For the final one, the third one, we essentially cascaded the low pass and the high pass filter. So we just took the output of the low pass filter and connected to the input of the high pass filter, and that was easily done by using this green wire over here. And this is our data. So essentially it's the combination of the low pass and high pass, which is why it drops down at the low part and it drops down at the high part. The amplification is especially big because it's both of them cascaded.
You're good.
Okay, so in terms of the negative 3 dB point, usually we actually make it negative 3 dB, but because it's amplified, and that means the negative 3 dB is going to be actually lower. So it's just negative 3 dB minus what is at the top. So in this case, because the maximum gain, it looks like it's 7 over here, then negative 3 dB is going to be 4, because 7 minus 3 equals 4.